Good afternoon. My name is Jose, and my project is about predicting mortality rates. I've been working at Pacific Life Re, a reinsurance company located just in front of London Tower. Pacific Life Re main business is reinsurance. And you may wonder what reinsurance is. Well, an insurance offers security against a financial risk. For example, against an income loss due to incapacity or a death. While a reinsurance company shares this risk and covers part of the expenses of the insurance company. So it is very important to understand this risk, because if the event covered by the policy happens, the insurer loses money. Pacific Life Re relies on statistical models built by actuaries. These models are based on tables and correction factors. However, I decided to do in a very different way by using machine learning. The idea is to use a tool that can predict mortality rate, taking into account some characteristics of this group. For example, age, gender, or smoking status. In this context, mortality rate is defined as the number of deaths over the number of policies. For this, I used a regression tree, which is a model that is based on a yes-no questions to predict the answer, the mortality rate. But better than that, I used many trees, which is called a random forest. So I pulled many trees, and then from there I took the average of them, and that's the prediction that I got. For this, I had to train the model. And for training, I used the data from a public data set, which is the American Society of Actuaries, containing 30 million life insurance policies. In this case, for example, year 2011, we observed 3 policies with female, age 70, non-smoker, and with a payout between $10,000 and $15,000. In this case, no death was observed. So here was a mortality 0. So after the training phase, I tested the model, and this is how it looks. So here we can see the mortality of the model against the mortality observed. Each point here represents a group. Here we can see that more or less they lie within the central line, which that would be the perfect match. They lie either side of the line, which indicates that more or less it's okay, it's relatively good within an error. But I was interested on seeing how the model performs with groups that are very similar, that they share almost all the characteristics but one. So I did this by taking 2 sets of inputs and varying gender. I put it in the model and I got this curve here. I did it at different ages, and we can see how mortality increases with the age, and we can see also that there is a difference between male and female, and male are more prone to die. This is something that the model was able to capture. So I said, let's do the same for a smoker status. So we have information about smokers and non-smokers. And here we see that, in fact, smokers, they have also more chance to die. So this is also another recommendation from machine learning, is that smoking kills. So this is another interesting thing, is that as we have information from different years, here we can see that mortality has been increasing from year 2009 for a particular group. This is 2009, 2011, 2013, and 2015. So between this range of age, there has been some increase in mortality. Another interesting thing here is the influence of the policy value. So this is the payout that one gets. And here we can see the black one. This is like in the range of millions. And this red one is less than $10,000. We can see that the rich people tend to live longer. So now let's see how this compares with the traditional actuarial methods. So here we can see the error, the relative error for all the data set made by my method against the traditional predictions done by the actuaries. And we see that the range of error is very similar. But what is very interesting is that there's been a significant improvement over the age of 60. And this is very, very interesting, because you can see this red curve here. It goes down, and then it gets almost 0 error. And this is very powerful, very interesting. So to conclude, machine learning models are very competitive compared with the traditional actuarial methods. In this project, machine learning predicts better than traditional actuarial methods for high ages. And I really think that machine learning can disrupt the actuarial methods by providing a very powerful predictive tool. Thank you very much. That's all.